In this video we're going to take a look at section 2 of the Python AppSec category on the Veracode Security Labs Community Edition. So it's free to register for these labs, and the second lab is called the Power of None. The description says, learn how untrusted user input and the non-constant in Python could allow for a complete bypass of the application's authentication controls. So we'll click start to begin the lab, and we've got our loading screen here. And it says the app's booting, so it's booted up a URL for us to visit. Let's have a look at the introduction first of all. And the introduction says we have a sample application with a common scenario. A user arrives at the application, and in order to use the service they need to create a login. Once they've registered, they can log into the application and begin to use the service. In this application, however, a secondary code, uniquely and randomly generated, is provided, which must be provided at the login process. When this code and username are entered, the two are verified, and if successful, the user login process is complete. Ideally, this code would be sent through second factors, two-factor authentication, such as an SMS message or Google Authenticator, something like that. But our application operates in isolation, so the code is provided during the login flow. To begin, type boot, which it's already done for us, it's booted this up, and then visit the URL for the app. So let's take a copy of this and open up in a new tab. Let's quickly have a look at the application. So it just says, welcome to this vulnerable application. The application is here to help you understand the importance of good input validation and secure comparison checks. We've got a login here, and we've got an option to register, so let's go straight to the registration. I'll register with crypto. User successfully registered. Let's try and log in. And it's given us this code 1538. We can copy it and go forward, and then we need to provide this code here. So we enter in crypto and then the code that it's given us from the last screen. So there's two steps to the authentication. Okay, and let's go back and go on to our next section. And I wonder, can we look at the code here as well? So we can have a look at the code, but let's move on to the next section. So here it tells us about the expected functionality. The user can register, can log in, and that you get the second authentication code. It tells us to register a new user and then complete the registration, and then we can continue to the next section. Testing the login. Okay, we also completed the login already. Try logging in with a new user. Copy the code and go through, and yep, we've done that as well. So in this section they're asking us to open up app.py in Pico. We already have the code open here. It's just talking about the registration function, saying that when a user registers, the code value starts with a default value of none, and then when the first part of the login is completed, the value is updated to the randomly generated value. When the user submits the user code page with the username and code, then the values are matched and the login is completed. So it's asking us, it's not allowing us to continue. We need to actually open this up in Pico by the looks of it. But here's our code here anyway. We can see that it takes the username and password, it makes sure the username exists, make sure the username is correct. It will hash the password, make sure that's correct as well, and then it will generate this random code. So let's go to terminal and open this up just to allow us to continue. Now we can go next. So this is where we're actually told about the vulnerability with the code value, and it says that once the user successfully logs in and completes the code verification, their code value is set back to none. And if a user doesn't submit a value for the code field in the form, the verification also sets the code value to none, the Python constant, not a string value. So if the attacker were to visit the user code page directly, which is that second stage after you've entered the password, if they were to visit that directly and enter in the username, just the username, and submit the form, the two values, none, the string, and none, the constant, are then passed to the secure compare method for evaluation. And inside the secure compare method, a byte length comparison of the two values is performed, ensuring they're the same. And in this case, in the case that either a new user or a user is already logged in, their code value is none. So whenever this comparison occurs, it equals and the match is successful. So why is this a problem? Since the final step is all that's required to successfully log in a user, an attacker can bypass the code requirement by not submitting a value for the code in the form and successfully log in as any user. So it's asking us to try and submit the form without a value for the code field, only filling in the username, and see what happens. Let's first go and have a look at the code and try and match up what it's talking about here. So if we scroll down to the user code root, whenever a get or post request is sent to this, we'll get, if the request is post, it's going to take the username, it's going to make sure the username's entered, it's going to request the code, and here's the important bit. So if not code, so if code is false basically, or code is none, or if code is the string none, then it's going to set code to none. So if we send a post request to user code and we haven't supplied none, or we've supplied we haven't supplied code as a parameter, or in the post data, or we've supplied it but we've called it non case sensitive in this case as well, then it'll set code to none. And then when we get down here to the secure compare function, it's comparing the code with the code that the user has. So if the user actually has the code assigned to none, so that was the issue here, it said if the user is already logged in, their code is set to none, or if it's a new user, it'll also be set to none, and in that case that's all that's required here. It's not requiring the password at this stage. So because these two stages are disconnected in that way, it's actually made although they've added two layers of security, it's actually made the application more insecure. So let's go and test this out. So we'll go back to the vulnerable app, and here we're already logged in, but it's just we're at the login screen again here. But if we go to, well, we need to go to the user code page directly. Oh, I could have just changed that one word. And if we just try to enter in crypto and not supply a code, then we successfully log in. Similarly, if we go back and let's do code here, if we supply crypto and none as a string, we should also get the same success. If we go back and try something else, we'll go back to code and say crypto and say none without a capital, you'll see error with the code provided. Alright, so let's move on to the next section. And this section is about fixing the comparison. So it says there are a few ways to fix this issue, but we're going to focus on changing the secure compare method as a centralized place to prevent this issue from popping up in other places too. Since the issue is in the comparison of the string none and the Python constant none, we need to ensure that the two values we're being provided are of the same type. In this case, we need to make sure they're both strings. So we need to verify the token's type essentially. And to continue with this, in order to click next, we need to try and update the secure compare function so that the result of the comparison function is correct when the inputs are a string of none and the non-Python constant. The function is a helper function located near the bottom of the file at line 143. Make your changes and save the file, and then you can test them like this. When the function does its job correctly, this should return false, and you'll be able to move on to the next section. So it says line 143. If we go down here, yep, we have this secure compare. So there's a few different ways we could solve this. At the moment we have this checked for the length, so why don't we just add we could say or here, or we could add another level to the if statement. We could say elif type of bytes 1, type of input 1 is not equal to, it's not equal to type of input 2, then also return false. It's not giving me correct indentation. Let's save that. Do I need to run? Save and run? I'll do save and run, and then we'll go to the terminal and run this command. Oh, can't use the keyboard shortcuts. Run that. Oh, indentation expected. Okay, it changed my indentation for some reason. That doesn't look... Oh, it's letting us go next. So let's try that again. Returns false. Okay, cool. So there'll be other ways that you can do that, but essentially we just wanted to validate that they're both of the same type. And we'll move on to the next section, which is a possible solution. And they say here that while there are several potential ways to fix the code, they wanted to update it so that the same check, to be sure that the same check is performed everywhere it's used. And this solution performs validation on the input, makes sure that both values are strings before continuing to the length validation. In order to check this, they make use of the isInstance function and the list of string types from the 6 compatibility library. Alright, so I guess this is a more secure way to do it. But the same sort of idea. They're checking to make sure what's entered is a string, and in a secure way, I just verified that they were both of the same type. Which maybe there's some vulnerabilities with that as well. It probably wasn't as secure as it should be. The two isInstance checks ensure that the two input values are both strings. Now if you try and submit the form with no value for the code field, the comparison fails. This is because of the code we added is doing some additional type checking to ensure that the values input 1 and input 2 are actually strings. Yeah. Presumably though, you can still enter the none as a token. I didn't notice any fixes to that. Alright, but this is a lab complete anyway. And in this lab we've learnt about some of the dangers of improper type handling and input validation. So we'll finish this off and move on to HTTP header injection.